Hello, I'm Eceyavuz. I'm a mechanical engineering student at Bilkent, and today I am going to make my experiment presentation. My experiment is about the influence of the circuit parameters on stored electrostatic energy. In this experiment, I will test how voltage, resistance, and capacitor configurations influence the time constant and stored energy. With these experimental data, I will construct graphs to visualize relationships and then compare them with theoretical expectations. In this experiment, we will use a multimeter, DC power supply, 3 identical capacitors, 3 different valued resistors, a cable set, and lastly, a chronometer. First, we start by measuring the values of the resistors. As you can see, the values we found are 153.6, 507.4, and 220.1. Since now we know the real values of the resistors, we can start with part 1 of the experiment. Here, I focused on the relationship between resistance and the time constant by keeping the capacitance fixed at 1000 microfarads and maintaining a constant initial voltage. I systematically varied the resistance using 3 distinct values. I repeated these steps at least 3 to 4 times to be sure about the experimental values. In the second part of the experiment, I investigated the energy storage capabilities of the capacitor. The theoretical framework suggests that potential energy stored in a capacitor is not linear, but rather proportional to the square of the voltage. To test this, I measured the discharge energy at 5, 15, and 20 volts. The steps were repeated 3 times here too. In the final step, after charging 3 capacitors by connecting them first in series and then in parallel, I measured the stored energy based on their discharge times. And again, the steps were repeated 3 times to be sure. The experimental results align almost perfectly with theoretical expectations, starting with the resistance analysis, where my data points follow the expected linear path, confirming that discharge time increases linearly with resistance. Similarly, plotting energy against voltage squared yields the predicted straight line, providing that stored energy is directly proportional to the square of the input voltage. Furthermore, the configuration analysis mirrors the theoretical pattern, demonstrating that parallel connections store significantly more energy than the series one. Collectively, these graphs confirm that our experimental data matches the theory, providing that standard formulas of RC circuits are accurate. Finally, my calculated error rates remained low, which are within acceptable scientific limits. These minor deviations were mainly caused by human reaction time during measurements and slight leakage currents in non-ideal capacitors. In conclusion, this experiment successfully varied the theoretical formulas for both the time constant and stored energy in RC circuits. Thank you for watching.